Hi, my name is Nick Riccioni. I'm President and CEO of DNE, S.E.A.L External Fixation Systems. This is Drew. He's usually with me or by himself out there in the field covering cases in the OR. We schedule some cases. It's a pretty good chance you'll see one of us there. Today I want to go over our S.E.A.L circular frame, all the applications it can be used for, what it does, why it's better than what's currently out. And like I said, some advantages to it. First thing I want to show you is our strut system and how it differs. Our strut system works where we have a angular correction clamp approximately on a ring going down to a foot plate or any other type of ring to a universal joint, and you have the ability to rotate, angulate this stuff, and totally compress. If this is on a ring, this is a foot plate, right down to the end. All right? So the reason this is important is everyone else's struts that currently exist, if this is a ring up here where the angular correction clamp is connected to, cannot fully go down to the very end. You can't go ring to ring on anyone else's system. This is why the normal strut that exists in this business right now opens and closes a gross amount, and then it fine-tunes a little bit with this threaded rod. It can grow and compress a little more. But this is the ability it has. This is the extent of its compress and distract. Where on one of my frames, for S.E.A.L frames, you have the ability to compress this ring totally down to the other ring. Alright? You have the ability to rotate, angulate, do whatever you want with these things because they go everywhere. Alright? I'll leave that there for now and go through a couple different type frames. This is a great system, our Aquinas frame. The reason it's so slick is we have what's called the motor piece anteriorly, whereas other systems that even have an Aquinas frame use a motor posteriorly. All right, and then you crank it down and it grows and all that stuff. We put ours anteriorly. Our system is simple and it's clean. It doesn't have a bunch of sloppy knobs and triggers to move things up and down. So you can literally put this foot plate on a leg and have this foot plate almost totally up and down. All right, we have this one set up. I'm going to use a drill to crank this down because it'll take me 3 days to turn a T-handle, walk this up. Normally when this is put on a patient, the patient is going to be turning this maybe a millimeter or so a day until she's at 90 degrees or more, wherever the surgeon wants her to be at. But I'm going to crank this up right away just so you can see we happen to have a drill hanging around. I do home improvements here in the office. So I'm going to show you with this drill, with this foot plate coming up, and in quick motion what this is going to look like. All right? All right? Moved it up quick with the drill back up to 90. That's pretty much the motion. It's smooth as can be all the way up. All right? For Aquinas, we've done a bunch of these cases. They've all turned out great. We have the hinges set up in the area where this one would be for a right foot. So we have the hinge for the medial malleoli pushed forward, up a little higher. Lateral malleoli, we have more posterior and lower to mimic the hinges at the exact level of the ankle joint. So it's a smooth motion coming back up. All right, that's our Aquinas frame. Another frame I want to go over with you is one of our Charcot frames. All right, this has the walking skis on the bottom. So if the surgeon wants the patient to walk, we have these skis on the bottom. This particular frame, what's been done on it is we have bent wire technique where you throw the wire through. If you have the midfoot, you want to compress back to the rear foot, bend the wires back, compress them, and it pulls the bones against each other to compress them. One of the unique features we have is our struts. If there was a big wound back here after the frame was put on, surgeons got to get at the wound, and in the upcoming office visits, you just pop the bolt out all right, and the strut will lay down for you so the surgeon can access and get in there. And because our frames and our struts are super strong, there's no effect on the rest of the frame. It's strong as can be. It'll go nowhere if you throw one strut off it. There's going to be a video on my website. It's going to be probably on there by the time this video makes it. You're going to see I have these things locked onto 2 rings and I drive an SUV on top of it. So we tested the hell out of the strength of these struts, and that ain't going to be happening with this type design. I'd gladly drive that same truck over a set of these with my competitors, and I'm going to guarantee they'll collapse. So strength-wise, these struts are killer. When the guy's done, surgeon's done addressing the wound, pop that right back up and lock it in with the bolt. All right, and you can pretty much tighten that on if you want to pull this one off. Anyone around there you want to pull off, you can. One of the unique things we have also that no one else has is our circular rings, our roughened surface. So anything we connect to them, any of these pins we lock on, everything is going to grip way better because the surface is like a sandblasted roughened surface. Everyone else pretty much has a smooth surface like the sides of these. So, you know, they have the ability to lock the pins on, but with this extra gripping motion, we believe that's an advantage. Like I said in other videos of ours, we pretty much test everything to make it super strong. If it's just okay or as much as our competitors, that's not good enough for us. You know, we deal in external fixation only. We don't have 5,000 products that we got to screw around with. So we make sure our X-Fix is the best. We currently have the best system on the market. We're told that all the time. We're in training videos of our competitors. They show a picture of our frame, and the lecturer is saying this is currently the best frame on the market, and that's us, S.E.A.L. That's what we have. It's because we only think external fixation, and we've got some really cool things coming out in the near future. One more thing I'll show you here. Well, 2 more things. If we got an IM rod, surgeon's putting an IM rod up into the patient. You know, we have different size lengths of our rail system where these bolts can be loosened. This can go up and down to wherever he needs to do it, whether he's putting a 150, 160, 180, 200, 220 millimeter nail in it, so that these pins and wires, you know, won't get in the way of the IM rod up in there. Another frame we have, in this situation, we have a surgeon who's doing ankle fusion, so he's going to just turn these down, compress the ankle, and a limb lengthening up here on top. So he's going to distract up here because he wants to grow bone, and he's going to compress this ankle down because when he makes his cuts, compresses the ankle, he's going to have shortening. He's going to do a lengthening up in this section. So we have our rails up here to lengthen, and we have the ankle fusion down here. Alrighty. So one more frame I'd like to show you. This right here is for like a midfoot correction, and what we do with this one is we have a 3/4 ring around the calcaneus. So you're going to pin in your 2 wires through the calcaneus. You're going to lock your tibial block in the tibia. And before you connect this ring, this 3/4 ring in the midfoot, to the rear foot 3/4 ring, you can throw your pins and lock this ring in exactly where you want it. Then you can connect these rails in. You have the ability, this is the exact frame also with no bone in it. You have the ability, once you have that bone cut and pinned in, to rotate, angulate, all right? Move up and down, in and out, wherever you want to. Put that midfoot, lock it in with these 4 clamps. After you locked it in the position you want, maybe you have a little bit of a space here. You can compress this down, it'll pull this in and fine tune it. You can distract this out, it'll pull this one out. So you can, after you grossly adjust where you want that bone, you can then fine tune it by turning the ends of these rails. The reason we have these little rubber stoppers on, these do nothing but allow you to angulate, rotate, and move things around without this coming off, okay? So these are specifically to give you the advantage of grossly adjusting things in kind of an aggressive manner, all right? Without having to worry about things slipping off. Once everything's locked in place and locked down, these things can either be left on or thrown out because you're locked in place. They don't hold anything, any kind of holding power to the frame. They're strictly, in the beginning, we assemble all frames with these on, so when a surgeon's doing any kind of adjusting, distracting, anything, he has those to bump against to lock them and hold them there. Once everything's locked, these are irrelevant. They have no holding power for anything to do with the final frame. Alrighty? That's pretty much it to the S.E.A.L external fixation circular frame. You're looking at doing ankle fusions, ankle distractions, limb lengthening, angular corrections, midfoot corrections, wound offloading, the ability to have spacers that can be connected one to the other, the ability on the struts to throw pins and wires at any level to connect, to grab stuff. Okay, one more frame I want to show you. Just a static frame that a surgeon might want to use. What we do for just a basic static frame is this is our static frame. We probably build 90 or more, 95% of the frames right here we build. It's either me or Drew building the frames. So if it's something that's going to be an angular correction or a Aquinas or whatever, we like to get either an x-ray or a picture of something so we have something to go by. No matter what frame we build, the surgeon can always adjust anything. He can have the distance increase between the foot plate and the first tibia ring. He can have it decreased. He can have longer rails, shorter rails, anything. We can do anything. What I want to show you here is for a basic static frame, a lot of times, you know, guys, if they're shooting wires in the midfoot or the forefoot, sometimes these rails, you know, a wire can come out by a rail. So what we did was, on a lot of these frames, we moved the anterior rails, our struts, and connect them to the half ring in front. So now you have this whole area in the foot plate to throw your wires without ever, you know, these things getting in the way. The advantage of these things also, like we showed earlier, is you can take this bolt out, pop this down, throw the wire through, connect it. You can always just loosen this bolt on this universal joint and move this over because these will move anywhere. So you can move these struts interoperatively, or you can put the struts right on the half ring in front, and you can see it locks it insanely solid, and then you can throw these things anywhere in the forefoot where you have no worry of the strut getting in the way. Thank you.